Greetings. In this lab, we want to titrate a solid unknown acid, and the challenge is we don't know how much acid we need to titrate. So we're going to take some of this unknown acid, and we're going to find out how much of that would be required to neutralize 25 mils of the base. So if I click on here, where is my NaOH? Now, in the real lab, you would want to use a dilutive solution. I'm going to use 1 molar and not waste my time diluting it. But in the real lab, it's both safer to use dilute solutions, but also the amount of products you consume and the waste you produce are reduced. So if I had used 0.1 molar NaOH, I would need only 1/10 as much of the unknown acid. Now, the question we're going to ask ourselves is how much of this unknown acid is required to neutralize 25 mils of the base. Then I will dilute that unknown acid into a water, and I'll do a titration, and I know my endpoint will be around 25 mils. So I'm going to go into the stock room, and I'm going to grab an Erlenmeyer flask, and to keep things visually simple, I'm going to use a different size. And I'm going to transfer 25 mils. So if I type here 25 and hit pour, I've transferred 25 mils into this flask. Now, I'm going to have to repeat this several times because I don't know how much a solid acid is required. So I'm going to right-click, go duplicate, right-click, go duplicate, right-click, go duplicate. Okay, they all jumped on top of each other. I'll just move them over here. So now I've got 4 bottles with 25 mils of 1 molar NaOH, and if I look at it, the pH is 14. Okay. Now, normally we would isolate from the environment, the surroundings, but this is my first try, so I'm just going to pour in 10 grams, hit pour, and notice the pH is 2.86. That means that there's more acid than there was base. I'm going to get rid of this, and I know that 10 grams is too much. So I'm now going to take 25 more mils of my base, and this time I'm going to add 1 gram. But now that I'm going to do it at a smaller amount, I'm going to go in here and I go to thermal properties. And because this is an exothermic reaction, that the temperature would change and then it would cool back down, and my numbers would be changing until it reached room temperature, which is 25. So I'm just going to maintain it at 25. So I'm going to click 1, and note the I hit pour, and the pH is 13.71. So that's 1, 2, 13.36, 3, 12.73, 4, 3.78. Okay, so it was more than 3 grams, but 4 grams was too much. So I'm going to go remove. I'm going to take another one, right-click, thermal properties, isolate from the surroundings, make it 25, click OK. And now I'm going to start off with 3 grams, okay? 3 grams, and I'm going to do a pour. And now I know if I added another gram, it would drop down way below the basic solution. So I'm going to just add 0.1. So now I'm going to hit pour, and now I have 3.1, 3.2, keep looking at the pH over there, 3.3, it's 12.26, 3.4, it's 11.8, I bet you were about there. So what was that, 3.4? 3.5, 5.8, so I would say 3.4 grams is around the amount. So what you want to do is you want to take 3.4 grams of this unknown solid, dissolve it in some water, and do a titration. And if you use this concentrated 1 molar NaOH, it will take you somewhere around 25 mils. It may be a little bit more because I underestimated the equivalence point. And but it's definitely within the range of your volumetric apparatus, and you'll be able to run your experiment. Now be careful. You should look at the solution at half equivalence. Make sure there's no solid. Now I'm not sure what will happen, but I'm just going to pour the entire contents of this 100 into there if I can find the pour button. Unfortunately, 100 pour. You see how there's a solid at the bottom? If you see a solid, then you have to dilute the solution. Okay, at half equivalence, the pH is equal to the pKa. So when you know the mass of the solid and you know the equivalence point, you can calculate the molar mass for monoprotic acid. At half equivalence, if everything is dissolved, pH equals pKa. If it's not dissolved, then you have to use more dilute solutions. Okay? Hopefully that helps.